Hello my dear students, welcome back to our J Prep channel. Hope all of you are doing well as usual. In the previous video we have studied what is the distance formula. So that formula was used to find the distance between any two points, that is under root x2 minus x1 the whole square plus y2 minus y1 the whole square. In today's lecture we are going to study sections formula. Now when to use sections formula? See, suppose you are given a segment AB. Suppose you are given this line segment AB, then point A has some coordinates x1, y1, point B has another coordinate x2, y2. And there is a point P which divides segment AB. When point P is in between point A and point B, then you call it as the internal division. And this point B cut segment AB into two parts, into two length segments, that is the length AP and length PB, segment AB and segment PB. So this length AP is taken as M and while length PB is taken as N. So we say that point P divides segment AB in the ratio M/N. Then how to find the coordinates of this point P which divides segment AB internally in the ratio M/N. Now let's see. Now here in the diagram we have a same line segment AB. Coordinates of point A are x1, y1. I have shown it here. Coordinates of point B are x2, y2. And there is a point P which divides segment AB in the ratio M/N, in the ratio M/N. So therefore length AP is M and length PB is N. Now what we will do, we will draw the perpendiculars from point A to x-axis and to y-axis. Also perpendiculars from point P and point B to x-axis and y-axis respectively. Then this distance is x1. Then this distance OD is x, then CD distance will be x minus x1. In the same way, OD is x while OE is x2. Therefore, this distance DE is x2 minus x. And in the same way, I have found this distance FG, that is y minus y1, and that is distance GH, that is y2 minus y. So when the GH distance is y2 minus y, then BR distance is also y2 minus y, and FG distance is y minus y1. Therefore PQ distance is also y minus y1. So what we will do, we will note down these distances. So therefore this distance AQ is equal to x minus x1. Distance PR is equal to x2 minus x. Then distance PQ is y minus y1, while distance BR is equal to y2 minus y. So now we have noted down these distances. Now what I will do, I will draw the perpendicular from point A to this segment PD, so that meets at point Q. And same way I will draw a perpendicular from point P to this BE, and that meets at point R. So have you realized, students, that you get two right angle triangles AQP and PRB. Can you guess, are they similar? Yes, they are similar, because this angle is 90 degree and this is also 90 degrees. So these are the two right angles, and this angle is congruent to this angle because they are the corresponding angles. So therefore we have these two triangles are similar. So we have two similar triangles. So which are the two similar triangles? This is triangle AQP is similar to triangle PRB. So let's write this as AQ upon PR is equal to QP upon RB is equal to AP. upon PB. Students, you must have noticed that AP is equal to M while PB is equal to N. So I can write this as AQ upon PR is equal to QP upon RB is equal to M upon N. But now we all know what is AQ, what is PR, what is PQ and what is RB. Just substitute these values here. So let's first choose this AQ upon PR is equal to M upon N. So AQ upon PR is equal to M upon N. Now what is AQ? This is X minus X1 upon X2 minus X is equal to M upon N. So cross multiply it, N into X minus X1 is equal to M into X2 minus X. So now let's simplify this further. This is Nx minus Nx1 is equal to Mx2 minus Mx. Take the terms containing x to one side. So this is Nx plus Mx is equal to Mx2 plus Nx1. So hence x into bracket M plus N is equal to Mx2 plus Nx1. Hence we get x is equal to Mx2 plus Nx1 divided by M plus N. So this is the x coordinate of the point P. So this is the x coordinate of point P. Now let's find the y coordinate of this point P. To find the y coordinate of this point P, we'll have to use this ratio QP upon RB is equal to M upon S. So we will equate these two ratios. So therefore this is QP upon RB is equal to M upon N. What is QP? PQ, that is y minus y1 divided by y2 minus y is equal to M upon N. So cross multiply this. This will be N into y minus y1 is equal to M into y2 minus y. So therefore this is ny minus ny1 is equal to my2 minus my. Hence it is ny plus my is equal to my2 plus ny1. So what I have done here, I have opened these brackets and then later on I have taken the term containing y to one side. So that is ny plus my is equal to my2 plus ny1, my2 plus ny1. So take y common from here, y into m plus n is equal to my2 plus ny1. So therefore y is equal to my2 plus ny1 divided by m plus n. So what are the coordinates of point P which divides segment AB internally? This is mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n. So these are the coordinates of point P which divides segment AB in the ratio ms to n internally. Why internally? Because point P is in between point A and B. Same way point P can be outside segment AB also. Then you say that point P is dividing segment AB in the ratio ms to n externally. Okay. So if Pxy divides segment AB externally in the ratio ms to n, then the x coordinate will be mx2 minus nx1 divided by m minus n, and y coordinate will be my2 minus ny1 divided by m minus n. So if the point P divides segment AB externally in the ratio mh to n, then the coordinates of point P are mx2 minus nx1 upon m minus n, while y coordinate will be my2 minus ny1 divided by m minus 1. Hope all of you understood the sections formula. And students, to understand these concepts of mathematics and physics, I strongly recommend all of you to subscribe to our channel. Thank you.